Hi, and welcome to Meetings in Math 2.5 Similar Figures. Your essential question is how can you determine if two figures are similar? And we're going to be working on a practice problem today. You're going to need your pen and pencil, your Jaguar Jots on section 2.5, the practice problem example number 1. And you need to bring your perseverance and your self-confidence. So we went over what makes a similar figure and kind of the different parts and the different pieces. And now I want to go over how do we do an example. And so what we're looking at is 3 different parallelograms. And we want to know which one is actually similar to parallelogram A. So parallelogram A is the one we're starting with. And then we're going to look at parallelogram B and C and try to figure out which one is similar to parallelogram A. And we're going to be looking at it by looking at the angles and the sides, because when we're looking for similar figures, we have to consider both angles and sides. So let's just talk about what do they look like and take care of the angles to begin with. So angles are pretty usually straightforward because we look at it and they either are or they are not. So let's begin with the angles. And the first thing that I see in parallelogram to A to B is I have 1 and 1, and I have the 1 and the 1, so that's good. And then I have 2 and 2, and I have 2 and 2. So the angles are fine there. And now let's go from A to C. And I have 1 and 1, and I got the 1 and the 1, and the 2 and the 2 and the 2 and the 2. And if I was to pick parallelogram C up and put it on top, they're all in the same places. So it goes 1, 2, 1, 2, 1, 2, 1, 2. And same with B. If I put it here, you can see that it would go 1, 2, 1, 2, and starting in the same place, it would go 1, 2, 1, 2. So everything's corresponding with angles, and that's fine, which means we're going to be spending most of our time looking at the ratios. And so the ratio of the sides are where we can get a little bit crazy. And so what I do is I always start off by looking at the ratios and I write down what it is I'm going to do. So for example, let's look at figure A to figure B, and then we're going to look at figure B, A to C. So since we're not doing that A to C, remember we can do masking. We've talked about that before. And when you mask it, you cover up what it is that you're not going to use. And so you can, at home, you can just use a Post-it note or a piece of paper, and you can cover up the piece that we're not going to use if it's a little bit confusing. So you can do whatever it is that you need to do. So I have a hint down here. And it says highlight the corresponding sides the same color. So why do we do that? Well, it helps our brain figure out what's going on. So when I'm looking at this, I have an 8 and a 12, a 4 and a 6, and a 6 and a 12. Okay? I'm ignoring C. So anything that has to do with C right now, I'm ignoring. And I'm only going to work on B. So that I only work on one piece at a time. So the 2 colors that I'm going to be using are going to be pink and blue, because that's what 2 colors I picked up. I'm going to go ahead and highlight the side that goes 2, 1 as pink. So it has to go 2, 1 as if I'm going around clockwise. So 2, 1 would be 4. Okay. That means that those are the corresponding sides. That means if I was to lay one on top of the other, they're in the same place. And then the other one's going to be blue. And again, this is just helping our brain see what's happening without getting confused, especially because there's no points labeled. There's nothing there to kind of help us anchor in and see what's happening. So I have my pink and my blue pins to help me out as well. If you don't have colors, that's okay. You can even just use a color crayon to help you out. But seeing the colors really do help with similar figures. Okay, we're always going to put figure A or parallelogram A on the top or our numerator, and B is going to be on our denominator. And remember, if they are similar figures, that means when I'm looking at my ratio of sides, they're going to be the same. So what I'm going to do is I'm going to compare the pink sides to the blue sides. And when I reduce it, the ratios are going to be the same. So here we go. In the first box, I'm just going to set up the ratios. So A to B, B to A, A to B, and A to B. So I'm going to do 12 is to 6, A to B, and 8 is to 4. Now, if this is a similar figure, that means I multiplied 8 by the same thing by 4 to get those proportional relationships. Same with 12 and 6. Okay, in order for that to work, they're going to have the same ratio. 12 is to 6 and 8 is to 4. Do they reduce to the same thing? So 12 is to 6 and 8 is to 4. Now I'm going to just go ahead and do the problem. So 12 is to 6 as 8 is to 4. I know 12 divided by 6 is 2. So this would be a 2-to-1 ratio. And 8 over 4 I also know is 6. So this would be a 2-to-1 ratio. So these have the same ratio. This is a 2-to-1 ratio from here to here. This is a 2-to-1 ratio from here to here. It actually is a 1-to-2 ratio. So the similarity ratio here is 1/2. This is half the size of this, right? Because it got smaller. So we do need to be careful and pay attention to the fact it got smaller. So it's 1/2. Small little things to pay attention to. So yes, this is a similar figure. So we would say yes, parallelogram B is similar to parallelogram A because the side ratios are the same. So let's go up to this question. All the parallelograms have congruent corresponding angles. Is that enough? So what do you think? Is that going to be enough? We've already figured out that these are similar. Does that guarantee then that these are going to be similar? What do you think? Let's go ahead and look at this one. What side corresponds with the 8? It is the 6. What side corresponds with the 12? It is the 12. So do you think that these are also similar? Let's go blue again. So 12 goes to 12, and then 8 goes to 6. Because A, right, was on the numerator and C was on the denominator. And we're going to go ahead and solve that. So 12 goes to 12 as 8 goes to 6. Keep them as a ratio, 12 or as a fraction. 12 goes to 12 is 1 or 1 over 1. And 8 divided by 6 are both divisible by 2. So this would be a 4-to-3 ratio. Now, are these congruent? Are these the same? No, they're not. So these cannot be similar. Remember, to be similar, they have to have the same ratios, and these do not have the same ratios. So these are not similar. So is it enough to have corresponding angles? The answer is no. The sides must be proportional as well. So we would say that parallelogram C is not similar to parallelogram A because the side ratios are not equal. So why do we care about whether or not they are not similar? Well, similarity helps us solve problems. So let's look at this. In this case, they're telling us, hey, the triangles, they are similar. So now we know that they are similar, that they have similarity to them. And so what we want to know is we want to find out how long is X. So we're going to do the exact same thing as far as setting up a similarity ratio, but now we're going to solve an equation. So we're going to go ahead and we're going to look for corresponding sides. So if I was to line this one up and I was going to put it inside of this, the 4 would correspond with what? Does it correspond with the X or does it correspond with the 6? Well, the 4 is in the same place as the 6. So the 4 and the 6 are going to go together. And then that means that the 8 and the X have to go together. So now we need to decide how we're going to set up our equation. We can either do small triangle over big triangle or big triangle over small triangle. And it really doesn't matter which way we do it. We just need to be consistent. I'm going to just do small triangle over big triangle. And so I'm going to write that down so I don't forget. And now I'm going to start setting up a similarity ratio. So small over big. So let's just go ahead and start with the blue. So the small side is 8 and the big side is X. And now let's do the pink. The small side is 4 and the big side is 6. And now we have an equation for us to solve. So we have to go back to solving proportions or solving equations. And we have to remember what it is that we do. So there's some different ways we can solve this one. We can multiply both sides by X to get the X moved up, or we can use cross product. And since we're in 8th grade, we can use cross product. 4 times X on this side, and on this side, 6 times 8. And now I have an equation that doesn't have all the fraction bars and makes it a little bit easier to solve. So now what do I want to do? I want to go ahead and 4 times X to undo multiplication. I'm going to do division. And now I can either do 6 times 8 is 48 and divide by 4, or I can do some reducing up front, which I always like to do. So I am going to do that. So I know that 4 goes into itself once and into 8 2 times. This is just so I can avoid using a calculator and dealing with big numbers. And now I have 6 times 2, and 4 over 4 is 1. 6 times 2 is 12. So 12 is equal to x, which means x is 12 centimeters. So we are able to find that missing side by using our similarity knowledge. So what I want you to do tonight is I want you to go back through the first example where we were looking at whether or not they were similar and figuring out and making sure you understand which ones were those corresponding parts and why it is one similar and one is not similar. Thank you so much for joining us today. And remember, be kind to one another because we can all use some extra kindness in our lives. Bye for now.